Hello guys, welcome back to another video on my channel, and this is going to be part 2 of the calculus series. And today we're going to be looking at some functions to differentiate, and we're also going to be introducing the chain rule. And so I have some practice questions that use the same concept that we learned in the last video in progressing levels of difficulty. So you're going to have to use the power rule here. But they should all be manageable, and I'm going to go through them in just a bit. So pause the video here and have a go at them now. Okay, so the first question, we're going to just use a power rule. So we're going to bring down the power and multiply the coefficient by it, and then we're going to subtract 1 from the power. So this is going to equal 15x squared. So this is f prime of x, the derivative that we learned about in last video. And then for the second one, we're going to do the same thing, but now we have to be a bit careful because when we subtract 1 from -3, that becomes -4, not -2. So this is going to be -5 times -3, and x to the -4. So be careful about subtracting from negative integers, but this is going to give 15x to the -4, and that's going to be our derivative. And our last problem was 3x plus 2 squared. So instead of writing squared, I'm just going to write 3x plus 2 again. And now before taking the derivative here, we need to expand the brackets, and we're going to get 9x squared plus 6x plus 6x plus 4. And now something about differentiation is you can do it to each part. So if you have a function that is composed of an addition of different functions, then you can take each part and differentiate it. So this is going to give 18x plus 6 plus 6, and 4 is actually 4x to the 0, so this is going to be 4 times 0, x to the -1, right? So that's just 0. So our derivative here is going to be 18x plus 12. But yeah, so those were the practice questions, and now I'm going to introduce a new rule called the chain rule. Okay, so the chain rule can be a bit intimidating, but with the use of an example, I think it's going to be a lot easier to understand. So the chain rule states that if we have a function, and that function has the input variable of another function, then what we can do is we can take the derivative of that function by doing the derivative of the function with respect to the input parameter times the derivative of the input function, the input parameter. So what that means basically is if you have something comprised of two functions, right, something like this, for example, so 3x plus 2 squared. 3x plus 2 is one of our functions, and something squared is another function. So in this case, our f of u would be squaring something, and then what we're going to input, our input parameter, would be 3x plus 2. And now we can do the derivative of the outside function, which is the f, with respect to the input parameter. So we're going to treat this basically as we would treat a single parameter. So like something like x, where we would have like x squared, this would be 2x, right? So we're treating the inside as if it's a single variable. And I know it's a function, but to fix for that mistake, we're going to take the derivative of u and multiply the whole thing by it at the end. So we're going to treat the 3x plus 2 as if it's just x, which is going to give us 2 times 3x plus 2 to the 1, right, if we differentiate, because we bring down the power and we subtract 1. But that's not true because 3x plus 2 isn't just x. So what we need to do now is we need to take the derivative of the inside which is going to give us just 3. Because this is 3, so let's just do that. 3x to the 1 plus 2x to the 0. So we bring this down and we subtract 1. This is going to be 3x to the 0 plus 2 times 0x to the negative 1. So this becomes 0 and that becomes 3. Okay, so the derivative of the inside is going to be 3. So here's the derivative of the overall function. And what we can do is we can expand and we can check. Because remember, we did this in our practice problems just a minute ago. And so what we can do is say 2 times 3 is 6x plus 4. So just multiplying the 2 inside. And we still have to do the 3. So it's going to give us 18x plus 12, which is what we got for the previous question as well, by expanding and taking the individual derivatives. So this chain rule is usually used for stuff when you can't expand, right? What if we had something like 3x plus 2 to the 10, right? Expanding and taking the individual derivatives here is going to take a long time. So what we would do is we would say, treat this as a single variable, and we would say that's 10 times 3x plus 2 to the 9. And then we would multiply that by the derivative of the inside, which is 3. And that would be our derivative without having to expand everything, just using the chain rule. But yeah, so we'll do some practice questions using the chain rule. Okay, so here are 2 questions, and if you want to have a go at them, you can pause the video now, because I'll be going over them. So, first we have 6x plus 5 raised to the 3rd power. And what we're going to do is we're going to treat 6x plus 5 as our u of x, so a single variable, and differentiating with respect to u of x is going to give 3 6x plus 5 squared. And now we have to take the derivative of u of x and multiply that by what we just got, because u of x isn't a single variable, it's a function itself. So the derivative of 6x plus 5 is, this is x to the 1, so that becomes 6. And then the 5 disappears because 5 is just, remember, 5 is x to the 1, x to the 0, sorry. And when you bring down that 0, the whole thing disappears. So the overall derivative is going to be 6 times 3, which is 18, and 6x plus 5 squared. And you can expand and simplify a bit further, but you can also just leave it like this. So our second problem has more terms inside, but that shouldn't make a difference, right? No matter how many terms that are inside, we can treat that as a single variable as long as we can then differentiate and multiply by what we just got. So we can treat this whole thing as u of x and say this is just going to be 4 times 6x squared plus 5x plus 3 cubed. And then we're just going to take the derivative of the inside, which is going to give 12x plus 5 plus 0. Because any constant, anything that doesn't have an x in it, has a hidden x to the 0. And when you differentiate it, you get 0 because you bring the power down. So any constant term, the ones that don't have x in them, are just going to go to 0 when you differentiate. So now we multiply this, and we can distribute the 4 to the other bracket, and that's our answer, that's our derivative. Okay, so that's the chain rule, and it's basically used in situations where you have 2 functions composed within one another. So you have this function 6x plus 5 is our first function, and that's kind of nested inside that squared function as well. So you have two functions that are within each other, and you treat the inside function as a single variable and then differentiate the outside function, but then remember to multiply what you just get by the derivative of the inside function. So that's just the chain rule, but it's not the only rule when differentiating, because we can have other scenarios when that don't fit the function within a function relationship, such as the product of two functions or the quotient of two functions, and those have their own rules, which will be covered in video 3 of the series. So I'll see you in the next one.